just barely, we're just barely going. We just barely started, so we're like on question number 3. We haven't really started talking about it, so.
Sorry, sorry I was late.
Well, it really is pretty amazing that the kids are so cooperative when you're just, they can hear you're up, and they do a really good job. All right, so find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25. Okay, so we use the confidence interval formula. Oh, find the margin of error formula, rather. Let's see where that is. Okay, so m equals z
Go to bed, okay? Confidence. Are they just asking for the Z score? Margin of error, but okay.
So I thought that was that
oh, there we go. I
formula
see it. Sorry.
that m equals the z-score, and then with the standard deviation
Sigma over
divided
the square root of n. Yeah, I see
so
it now. I was looking at the wrong formula.
Okay, the standard deviation times the z-score times the standard deviation. What's the standard deviation? 50. All right, so then for the 90% confidence level, that number is, let's see, the z-score is 1.645. So it's 1.645 times 50 divided by square root of 25.
Which is 5.
All right, so we have, so it's, do you know this, 6, do you have this formula, Joseph?
I'm still looking for the equation here.
Times 50.
Oh, Joseph, the equation. Oh, no. Sorry. Oh, no. Instead of opening up the textbook, I just shut it. Give me a second. I'll tell you where it is. But it's m equals, so confidence rate or whatever, equals z multiplied by sigma over the square root of n.
So it's z-score multiplied by what?
Sigma, so standard deviation.
16.45. So I got 16.45.
That's what I got too. Just doesn't that sound high?
Yeah, it seems really high. Does not seem like a margin of error, but
Okay. And it's in the textbook under 4.5.
4.5.
yeah. So there's just a, and then you use for the z-score. They have a chart that says what they are for 90, 95, and 99%. So I just made a note of that. I bet we're going to have to use that a lot.
Sorry, you made a note of what?
Oh, just of what the z-scores are for 90, 95, 99%.
Okay, so what did you get for number 3?
We both got 16.45. It just seems so high to me.
Hmm.
90%?
So what you do is you go to your standard whatever, the applet, and you do 90, like 0.9 at the top for probability, and you take that z-score. And then you multiply it by the standard deviation divided by the square root of n.
Okay. I got 1.26.
Okay, how did you get that?
Well, you said it's the z-score times the standard deviation, right?
So 1.645 times 50.
The z-score I got was 0.126.
So they give those to us on. There's a chart on the that says the z-score for 90% is 1.645. For 95% is 1.960,
Okay.
and 99 is 2.576.
Joseph, are you multiplying sigma by z and then dividing it by the square root of n?
Yeah, I had the wrong z-score.
Oh,
And
okay.
you have the two. It's the two. So you put in the 90 up in the area, and so 0.90, and then you use without the tails, either tail. You just do the middle sections, and that'll give you the z-scores.
Okay.
But there's a table that tells us if you go to section 4.1.4, there's a table that says confidence level and it says the z-score for those confidence levels.
Yeah, so you don't have to figure that out.
Okay. Yeah, I always get confused with the which equations to use every time. Okay, I got 16.45.
Okay.
Okay.
I had the wrong number in for the
Sounds
Z.
good. Okay, so question 4. Do you guys remember reading that in the textbook?
No. I'm thinking, this is,
I don't. Okay, I'm so glad. I don't remember it either, and I was like, what the heck? Okay.
which of the following, all right, let's see. Is a point, let's see. Point estimator to range of point. Well, I was thinking I would like to know what all those things are and see if, gee. So the standard deviation squared is an interval estimator of,
There's a table for point estimators in 3.1.
Okay.
okay, so, oh, a point estimator? Okay, let's see what that says.
Oh, it's there. X is a point estimator of U. Isn't that right?
Yes.
Okay. Thanks.
Mm-hmm.
Okay.
95% confidence level here.
So that's 0.165. Hiram, get your little bum in bed. Okay. Good night.
What
Time
is
to
that?
bed.
That X bar is a point estimator of mu. What does that mean? How can X bar, because, so the sample mean, the sample point estimator of mu? I don't get what that means. I'll go back and read it though.
Simple sample. Yes. Okay, what did you guys get for number 5?
I'm sorry, I haven't gotten that yet.
What
Have
is
you?
what's the formula?
Isn't it the last one we just used?
The point estimate.
Yeah, it's just a table, I think. That's what I can see.
So the point estimate is
It
the
could-
same as the margin of error?
Oh, it's 526. X, the sample statistic, is the same as the population parameter, and that's a point estimator, so 526.
So X is the
You
answer
guys
for,
agree?
for 5?
So 526.
I think so, because
X bar equals the parameter, which is the same as the point estimate. Okay, so point estimate is, okay, yeah, that's what my note says. The point estimator is the number on a line that is used to estimate a parameter. So that would be the point estimate.
So the point estimator, it's a number on a line that's used to estimate.
Well, what does it say? The number of the line to estimate a parameter.
Okay.
trying to say, do you remember how in previous lessons they were asking us like U is always equal to X? X bar, do you know what I mean?
Yeah.
And then we would have to translate sigma. I think that's all this is saying, but they're calling it the point estimator now.
Okay.
Yeah.
Or
Well,
the point estimate.
Oh, yeah. They
But I
wanted
think
to know what
thing
everything is.
So they just gave it a new name, but it's the same thing, same concept.
Okay. I have the margin of error for the next one. 27.5.
What did you get? Oh, I got a different margin of error.
We used the same equation as before, right?
But now it's the 95%.
So it's 1.96 times 113 divided by 8. Right?
Oh, you know what? Sorry, it is divided by 8. I put 526 in instead of 64.
Oh, okay.
So you're right. Is it just me, or do these seem other?
Well, yeah, 27%, 20,
That's either way.
almost 20 points.
That's like
Yeah.
50%, because it's 27% above the mean and beneath the mean.
Yeah. I don't know. It seems crazy.
Like, I don't believe our answer's wrong. I'm just don't.
No, just seems,
It just
yeah,
high.
this seems crazy.
What is the lower limit of this confidence interval?
Well, I don't think it's too crazy.
Is that...
X is 526.
I was just going to say, that's 526 minus that, right?
Yeah, that's a drop
So I guess that makes sense.
when it's 500.
So it's not percent. It's not percent. It's like actual
Point.
number.
Yeah, it's points.
Oh.
Yeah.
Okay.
Okay, the lower limit of this confidence level.
And that's 3 decimal places? I got 498.315.
Okay, what do we do for that? I can't find this.
So we just take 526 and we subtract. We do 526 minus 27.685.
Oh.
That's how I understand it.
Yeah, because
Is that right?
Right. I think that's what it is, because that's what. Yeah.
Okay.
So What'd you get?
498.315.
Okay. 498.315.
So that was like when they said, you know, that it's 49%, this candidate has 49%, and the margin of error is 3, and so it would be the range between the bottom limit would be 46 and the upper limit would be 42 or 52.
Right.
So that's just asking that same question.
Yeah.
Okay.
And I think I was thinking it was percentages because I've always read margin of confidence in percentages because I've always read it for, political studies. I guess it's not just percentages, it's just a number, but if you're using percentages, that's, yeah.
Okay.
It's not the percent, it's just the number.
Okie doke. The upper limit, that'd be the opposite. So,
If she increased the sample size, the margin of error would decrease, right?
I wrote that down. Let's
Here,
see.
I'll just.
All right. So what would happen to the
Yeah, it
interval
decreased.
if the sample size was increased? If n is increased, then the square root of n would increase, and the fraction would increase, which would lead to a smaller margin of error. So if the sample size is increased,
Right.
the width of the confidence interval will decrease or become narrower.
okay.
Okay, 99 confidence. Oops. Too late.
Wait, so if the sample size increases, the confidence level decreases.
Wait, but if the confidence interval increases, then, like, you go from 95 to 99, then the margin of error also increases.
To increase the sample size. Width.
Okay, so 9 should be decreased and 10 should be increased.
Correct.
Okay. Right, cool.
So do either of you click on the thing when it says click on this if you love math?
I did not click on that.
What?
Do you
I didn't
do that?
even see that.
Oh, yeah. Just about every lesson, there's a part in the text that says it gives you some information. Then it says click on this if you love math. So they don't want to confuse people that, I guess, but I never click on it. I think I'm afraid I'm going to
Don't want to read it?
Well, I just feel like it's going to confuse me if I read something else, but I don't know.
Okay, what is question 11 asking? They're planning a study. They
You define the
know the
sample
standard deviation is 400. They
So-
want a 95 confidence interval. So we're just solving for n, right?
Yes.
Yeah, so we have to solve for n.
Okay. That's
just a margin of error.
Okay.
And the score is 5.
Yeah, I got 246.
46.
Could be wrong.
I haven't gotten that.
Here, let me plug it in up here. 246.
There.
Oh, come on.
1.16 times 400 equals 784.
I have that being like really close to being right. That gives me 49.98 when I plug it into my.
So 7. How do you have that high of a number? Let's see. So 784 divided by 50. I'm not doing that right. Equals 15.68, and then you square it.
So 245.8624. But it says to round to the
Yeah,
nearest
that's
whole
what I got. Oh.
So the nearest whole number would be 246.
Yeah.
Right?
Pardon me?
So because
Yeah, no, you're right.
Okay.
All right, so what does it say? So I got 245.86. Okay, yeah, so they say you have to always round it up because you can't do a part of a person.
Yeah.
So it's got to be 246. So you
Right.
round it to the nearest whole number.
Yeah.
Because you've got to actually do people.
How did you do the math for that? Because I'm doing it wrong.
So you
That
do
is. Oh, go ahead.
you do the since it's what was it 95, right? Percent? Yeah. You do 1.96 times 400, and that gives you an answer. Now,
Right.
we want to find out what's going to equal 50. So we divide that by 50, and that gives us
15.68.
yeah, and then you square that.
Square it.
Oh, and then we could do this. We could square that. Okay. Thank you. I got the 15.68, and then okay.
Yeah, then you got to square it.
Right.
All right, well, this stuff, now this doesn't seem, I guess we haven't checked our answers yet, but this stuff seems a lot easier than some of the other stuff we've done. Oops. How many more do we have? Oh, we've got 3 more questions.
All right.
Okay. Oh, so that's interesting. My son was thinking about being an actuary.
Oh,
He was going to major in actuary.
it's a really good line of work to go into.
Yeah. I think he's
What
thinking.
did he decide to do instead?
Well, I think he's thinking about finance now. He just didn't. He didn't love. He's really good in statistics. Oh, so that's my son that I call for help.
Yeah.
But he just didn't. He didn't love it. So he just thinks finance.
You know what? I think I used to work with a whole bunch of actuaries, and I really think it takes a certain personality
Yeah.
to be able to love it. Do you know what I mean?
Yeah.
Like, it can be really, really dry.
Could be dry, right? And he's really he's into people, and he has just. I don't think just sitting behind a desk working with numbers all day would be the right thing for him. So.
None of the actuaries I worked with were people.
We're people. People persons. Okay.
They were all
all right. Oh, well, then that's not too bad, because then we just have to do the lower limit and the higher limit of the confidence interval. Okay, so let's see. Which are we going to use? Oh, maybe we don't have to do anything, because the standard, well, that's easy, right? We just take 100,000 and subtract 36,730, right?
36,730.
Well, you take away the standard deviation. Oh, no, let's see. No, you take away the standard deviation.
No, we have to find, yeah.
Or do we have, I guess we have to find the confidence interval. Darn it!
We have to find M.
Yeah. All right. That makes sense.
So I got.
I thought that was too easy.
I got 88,001 and 53 cents. Oh, nearest whole number.
Okay, I'm just doing the math. Sorry.
Okay.
So what did you get?
I got 88002.
88002. So $88,002.
Yes. Because we do, if I'm looking at this correctly, we would do the z-score times
that the standard deviation.
Yeah.
And then we divide that by
6. Because square root of 36 is 6. Or
I'm just. I'm just not on my game tonight.
Now, when did you start rounding?
Sorry, Joseph?
What's up?
When did you round?
After I did all of the computing.
Okay. So you took that one.
I got 99,000.
What did you get for the confidence interval?
I got 99,000, but I used the 11,000 instead of the 100,000.
Okay, which one are we supposed to use?
Or the 111,000. I thought we needed to use the 111,000 instead of the 100,000.
I guess that makes sense.
Because it's the confidence interval. Yeah, because it's the confidence interval for their study. So I got $99,002. That's just what I got.
Okay.
All right, so I'm not, let's see, darn.
Okay, so 99002 and then 122999.
Yeah.
And then question 14.
So what did I miss? All right, so what is the lower limit of this confidence interval?
So you get the interval, which you know that equation, and then you subtract it from the 111,000, not the 100,000.
So that's
5%.
99,000.
$99,002.
So you take $99,002 away from $1,100. I mean, 111,000, right?
Correct.
And what does that equal?
It should be 99002.
99002. Oh, so that should be it.
Yeah. And then you switch it up because the next question says what's the higher limit.
You add it.
So you add instead, that should be 122,999.
Okay.
Which leaves us at number 14. I said above all of the above.
Yeah, that's what I got too.
Okay.
Yeah. I wrote those down.
Okay, we got 100%.
Did we?
Yep.
I shouldn't be surprised, but I am.
So
Not you guys.
so I just got to figure this out. Just look at that last question about. So it went
go over it?
through, and it said, so it gave us more information. So they started with that, what they estimated the mean would be at 100,000, but then after they went ahead and did another study, then they found out that it was, so I got 89%. So what did I do wrong?
Do you want me to do the answers with you?
Let me see what I missed.
Hey, Joseph, if you want to go to bed, like I know it's later there.
One of one, one of one. Oh, 0 of 0.5. Oh. Okay,
Hey.
so I got question 8 wrong.
Okay. I will see you guys Thursday night.
Okay. All right. Thank you. Get a good night's sleep.
All right.
Sounds good. What did you put for question 8?
Yeah, what did I do wrong? All right, so the lower limit was...
Do you know what you got?
Huh?
I got 553,685.
Okay, well, I did you know what? I probably just forgot to put the 6 in because I put 0.85. I probably just put it in wrong. And then what is the margin of error?
Oh,
and
what is bummer.
What is the margin of error for the 95% interval? Wasn't 27.85 for question 6?
Maybe your 6s aren't working because it's 27.685.
Wow. Yeah, maybe that's happening. Oh, well, that's annoying.
Yeah, it's really annoying.
27.685?
Yeah.
Huh. Well, it's too bad you can't just go back and change the, although, it's like a difference of 1/4 of a point all told. It's so, I went and looked under the
I
grades
know.
today, and it's just such a, but it's nice to have the right answers to, I think it makes sense to put them on there. Wow, that's weird. Okay, I can do this. So thank
Do you
you.
want to go over the last?
Well,
Did you want to go over the last question? You could.
You know, I'll figure it out. I'll just I'll go and watch the that part of the homework. I mean, I think I understand it because I think it's all about that they went ahead and took that original information, but then once the research was done, then they found more information for that specific population, and then so that's what you use. Is that right?
Right.
Okay.
Yeah, because we're testing the lower and higher limits of their test.
Right. Okay.
Yeah.
Well,
So you have to use the 100,000, the 111,000 for the confidence interval because that's the statistic, not the parameter.
Oh, that's right. Oh, you stated that so well.
Thank you.
That makes sense. Okay. Yeah, I've got it. I'll just... And then when do you usually take the quiz?
Either tonight or tomorrow. Either tonight or tomorrow. How about you? Do you take it tonight?
I usually take it just that night if I feel like I know it well enough, but I think this one, I think I'll go and
I would go ahead and try.
I mean, this actually seems pretty easy because they're not, we only have a couple formulas to use, so as long as you put the right numbers in there.
Yeah, I do think this is all easy stuff. It took me a second to get it, but now I have it. Like, I understand it, and I don't think it's too bad. Can you explain to me, from last week, do you know when you have your Z-score, and you have to tell if it's left-tailed or right-tailed or double-tailed? Do you know what I'm talking about?
Yes.
And you put it into the applet to get, I got that wrong on my homework quiz, and I'm not sure what I'm doing wrong on that.
Well, I got that one wrong too. Let me look at it because I thought for sure that it was the middle section. I mean, it seemed whatever I did. Let me see. Do you know what number that was?
When I looked at the textbook, I was like, okay, this is right-tailed. When I looked at the textbook, it said for right-tailed, you have to do the left and the right. But then it's like 99 point whatever, and the answer was 0.0241. And I was like, okay, I don't know what I'm doing wrong.
0.0241 was the answer?
I don't remember. It was something
well, whatever.
Around
oh, so how did you figure it out? Did you, because what I thought I had done wrong is that I hadn't put in the third...
shaded the right area?
No, I was sure I had shaded the right area. But let's see. Let me look at this.
Because I got the Z-score part right.
Yeah, me too.
It was something about me putting it in the probability applet.
Well, I know. That's why I thought.
Okay, so I'm not the only one then.
With that. Yeah, because that threw me off. I thought, well, if my Z-score is right, that's the thing. And I just followed the, let's see. Oh, I have my notes here. So I was actually, I'm going to talk to Sister Wilkinson in the morning. And I was going to ask her about that because I thought I had followed everything exactly right.
I did too. I am so confused. What time is the meeting? And I'm sure if someone explains it to me, I'll get it. Do you know what I mean? Like, I'm sure if someone's like, this is what it is, I'll be like, oh. But right now, just reading the textbook, I've read it a few times, and I'm like, I don't understand how I am doing this wrong. What time is the meeting in the morning?
Well, so I'm just having one to go over my exam with her.
Oh, I see. I want to go to that. I should ask her.
Yeah.
Because I just want to know what questions I got wrong.
Yeah, you're welcome to come. So which?
Do you mind?
Oh, not at all. So I'll send you the link. I mean, it's just, she said the link in her, whatever it is, the instructor page, that the link to her thing.
Right.
What time let me check on that. So where is that? Because it was like, yeah, I think there was only that one. Yeah, and I thought if I got the Z-score, that just baffled me.
Okay, I am so glad because I was like, hey, and I got this wrong, and I couldn't figure out what I did wrong.
Okay. Yeah, well, I got it wrong too, which is really, all right. So I was going to ask her about that, and then, okay. All right. But yeah, come.
Yeah, I'll try not to, like, I know it's your meeting. I'll try not to take it over, but I'm just so confused, and there's a couple things I didn't get, and so if I could just hear her explain it.
Okay. Yeah. Well, that's perfect because I definitely was going to ask her about that. So let me look at my calendar and see what time we're meeting. So California time, it's 8:30 a.m. So it's 9:30 Mountain time.
Can you ask me that again?
So it's 9:30 Mountain time that I'm meeting with her.
That's like Utah time, right?
Right.
Okay, yeah, that's my time too. If I'm not there, please don't wait for me.
Okay.
I will or anything, but if I can make it, I'm going to pop in. Okay. If you don't mind.
Oh no, that'd be fine. Okay. All right, and if you don't make it, I will take notes on what she says.
Thank you. I appreciate it.
Okay. All right. Well, good night and thank you.
I might even just ask her to email me I think I got 3 questions wrong, and I might even just ask her to email me those, just so I can just go back through and find the answers on my own, but yeah.
So do you want me to, well, I mean, she probably won't tell me. I don't think she can tell me your scores or anything, which questions you missed. She'd probably
I don't mind. I mean,
well, but I think she legally can't. I don't know. Maybe
okay.
can, but
I'm not, yeah. I mean, if she can, and if she's like, oh, you both got this wrong, great. If she can't, I don't mind. I can email her about it. I just would really like to know what I didn't do right, especially since tests are 60%.
I
And I feel like
know.
I need to be perfect on the next one.
I know that's so important.
I have this other class, and I feel like the assignments are really ambiguous. Did you take 360?
Family 360?
Yeah, stress and coping.
Oh, isn't 360 marriage and family? Marriage 360? Maybe not. No, I haven't.
No, it's
Stress.
stress and coping.
Okay. No, I haven't taken the.
Well, anyway, I feel like the assignment. I feel like the assignment is ambiguous, and